Okay, so now we're going to look at how to graph equations of lines or how to write equations of lines. Eventually, our goal is to move away from requiring a table of values for each of these. So we're going to look at how is it possible to graph without creating a table of values. Okay, so for this first example, you either had the choice to print and follow along, or you could be sketching these on a piece of paper or on a piece of graph paper. Start by writing a rule for this leaf pattern. So I want you to write a rule and see what you can come up with. And then try graphing it, and then we are going to press play when you're ready. Okay, so if I'm looking at how much my leaf pattern is growing by, this leaf pattern is growing by 1 every time my position number goes up by 2. So remember, my rate of change, my A value, is my change of my pattern. So I've got a rate of change of 1/2. That means for every position value, I'm gaining half of a leaf. And if I work backwards to position 0, I'm going to have 0 leaves in that pattern. So my rule in this case is y equals 1/2 x. And I might choose to write this plus 0 in if I need to see it, but I don't need to see it. Okay, so to plot this, the pattern is very similar to a table of values. I can go in position 0, I've got 0. In position 2, I have 1. In position 4, I have 2. In position 6, I have 3. And then I'm going to take my ruler and I'm going to connect my points. So hopefully everyone's using a ruler. We're going to extend this to both sides of the graph. I apologize, I don't have a ruler on my iPad, so I'm not able to use one. Okay, so as we said, that rule, y equals 1/2 x plus 0. So we'll notice that this 0, the y-intercept, means that my graph passes my y-axis. So my y-axis is my up and down axis at the point 0. And then my A value, my rate of change, is 1/2. So this 1 is my rise and this 2 is my run. Meaning that if I scroll in, I'm going to go up 1/2, up 1/2. So this is my rate of change staircase. Okay, we're going to try that on the next example. Take a moment, press pause, try to graph t is equal to -5n plus 6. Okay, so if I look at this example, I know that my rate of change, my A value, is equal to -5. If it's not on top of something, it's over 1. So this is my rise and my run value. And my constant, or my initial value, or my y-intercept, these are all words that we use for this final term, or my constant term, is 6. So I'm going to choose to start by plotting my y-intercept first. So I'm going to plot my y-intercept, so 6. And then I'm going to use my rise over run. So in this case, my rise over run is -5/1. So this means down 5/1. So I'm going to go down 5, 1, 2, 3, 4, 5, down 5/1. And I'm going to put a dot. And then I'm going to continue to do that until I've got a couple points that I can connect using a ruler. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. And then, as I said, then you're going to take your ruler and you're going to connect your points. Okay, so there you are. Take a moment and try the next one. Y is equal to 3/4 x minus 5. All right, so hopefully you've pushed pause, you've tried graphing this. So I always start by identifying my rate of change, my 3/5, and my constant, -5. So I'm going to start by plotting this constant value, or my y-intercept value. So my y-intercept value is -5, so I'm going to put that on the y-axis. And then I'm going to use my rise over my run. So my rise is 3, so I'm going to go up 3, 1, 2, 3, and then over 4, 1, 2, 3, 4, and then put the next dot. And I'm going to do that again, 1, 2, 3, 1, 2, 3, 4. And one thing to check, my line is increasing, meaning that as I read it from left to right, it's going up. So I know that I've drawn a positive rate of change because my line is going up. All right, let's try the next one. Can you graph y is equal to -2x plus 6? Pause the video and try this. All right, so my a is -2 over 1. Things that I'm thinking to myself right away is that I have this negative rate of change, and I know that my negative rate of change means decrease, so my line's going to have to be going down. And I have an initial value of 6, or a y-intercept of 6. So I'm going to plot that y-intercept first at 6, and then I'm going to apply that a value. So I'm going to go down 2 over 1. So down 2 over 1, down 2 over 1. And I'm just going to keep doing that until I have quite a few points to add to or connect with my ruler. There we go. And that's how we graph equations of lines. So you start by plotting your y-intercept, and then you use your rise over run to get to your next point. Okay. The other thing that sometimes happens is you might be given a graph and you have to come up with an equation. So I'm going to ask you to push pause. I want you to see if you can come up with equations for these lines. Okay, so very similar to when I am graphing equations of lines, the two things I need, one, I need a rate of change, an initial value, or a y-intercept, and I need a rate of change. So the steepness of my line. So I'm going to start by finding my initial value to figure out where my line crosses my y-axis. So I'm going to write b equals, and in this case it's -9. And then I'm going to find my rise over my run to find my a value. So I'm going to go along my line and find another nice point. So when I say another nice point, what I mean is a point that my line crosses directly through one of the grid lines on the graph. So then I'm going to go up 3 over 1, and I'm going to check again, make sure that I'm the same, 3 over 1. So I know that I've got +3 over 1, and if I divide that out, it creates a nice number of just +3. So if I'm writing my equation of this line, I'm going to have y equals 3x, because that's my rate of change, -9, which is my initial value. Okay, let's try another one. Press pause and then press play when you're ready. Okay, again, we need two things. We need the y-intercept, or the initial value, and we need the rate of change. When I look at my graph, my line crosses my y-axis at -4, so my rate of change, my y-intercept is -4, so I'm going to write that on my graph. And then to find my rate of change, I'm going to go back to my equation, rise over run, and I'm going to plot those nice points on my graph. So I'm going to look to see where does my line cross some nice coordinate values. In this case, I go down 2 over 1, down 2 over 1. So my rise is -2 over 1, and when I divide that nicely, it's -2. So my equation is y equals -2x minus 4. Right, we're going to try another one. Okay, yet again, it's always the same process. Start by finding your y-intercept. Find your rate of change. So in this case, my y-intercept is positive 6. So b equals 6. And I have to find nice points on my graph. So there's not a nice point at 1, but there is a nice point at 2. So I'm going to plot a point there, and then I'm going to keep going and find another nice point. There's one right there at 4. So to get to that nice point, remember I'm trying to find my rise and my run. I'm going to go down 3 over 2. Down 3 over 2. So my rise is down 3 over 2. Since that doesn't divide out nicely, I leave it just like that. So my equation is y equals negative 3 over 2x plus 6. And there is my equation of this line. And then I have one challenge question for you. I want you to press pause, try this question, and then come back when you're ready. Okay, in this case, the thing that is missing is I cannot find my y-intercept. So eventually I might have to work backwards to that to find my rate of change. Some people, when doing a question like this, they might feel more comfortable using a table of values. And that's okay if you feel more comfortable using a table of values. That's something that you can choose to do. So if I look here, I'm going down 2, which I can see in my table of values, and I'm going right 1, going up 1. So that means that my rate of change, my rise over my run, is equal to negative 2 over 1. So far in my equation, I have y equals negative 2x. Now I just need to figure out what goes here for my initial value. Well, if you have the table of values, you could work backwards. So if I'm trying to get back to 0, I have to subtract 2. So that means I'm going to subtract 2 times. So if I subtract 4 from 7, I end up with an initial value of positive. I'm going to add 4, not subtract 4. So I'm going to get an initial value of 11. So plus 11. And there we go. When writing equations of lines, remember all you need to do is find your initial value and then use rise over run to find the rate of change.